Manishvati Michael? That's it. That's all I know. Thank you very much. So my name is Michael Amundsen, and the topic is continuous API management. That's a lot. That's a lot to think about, right? So it's continuous like DevOps is continuous, but it's APIs, and it's management like not coding, right? So there's a lot there. This is how you find me. I travel a lot. This year, I think it's going to be about 40 weeks on the road somewhere in the world. And I'm trying to cut back to maybe 35 next year. But you can find me on LinkedIn and Twitter and GitHub, and I would love to connect with you, learn what you're working on, what your challenges are, and what's interesting to you. You can also find me here. I have a website. I do on-site training, remote training, and authoring content, things like that. You'll find more about things there if you wish. I'm sponsored partly on this trip by API Academy, which is an amazing group of really smart people. I'm so honored to be a part of them. They're sponsored by a company called CA Technologies, big mainframes and other things. And they have this small group where we visit customers and we talk to them or clients. We go on public conferences like this, and we write, do research and writing, and that's all we do. We don't have to actually sell a product or anything. We can say lots of things and leave. So it's a lot of fun, and we learn a lot in the process. And every couple of years, we write a book. This is the second book our group wrote, and it's really the product of all of the things we've learned when we're talking to people in small companies and large companies about how they manage to create lots of APIs and get them to work together. So this book is actually just released online this week, and it will be available in print next week. We're doing a signing event in Paris next week. And I'm so happy to be a part of this group. It's a bit of a hefty book. It's about 300 pages. I'm going to try to distill the elements of that research. It took us a little over a year to write into these 40 minutes. Let's see how I do. So there's a few things. I want to talk about API management in general, this notion of what does it mean and why is it interesting and why is it especially challenging. A key element we've learned over and over again for people creating successful APIs is to treat the API as a product. All of the things that products have, life cycles and target audiences and measurements and successes and failures and redesigns and all these other things are really key. We'll talk a little bit about teams and roles. There's lots of talk in APIs and in microservices about how large a team should be or how small a team should be. And we're finding that actually the size doesn't matter, but the roles do. The actual responsibilities matter quite a bit. Then the last thing I want to talk about is something that my colleague Eric Vilda on the Academy has introduced. In this, he uses the phrase API landscape. There's a completely different set of problems when you have more than one API. So the problem of creating an API and designing it and getting it to work and having the formats and the documentation and blah, 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 all that, that's one set of tough problems. But when you have many of them, and some of our customers have thousands of them scattered across the globe, it's an entirely new set of problems, and it's worth paying attention to. And hopefully you'll find a theme throughout all of this. The biggest challenge to any of this management is time. If time stood still, it would be so much easier, but it doesn't, and that's a big part of it. So we'll have some final thoughts on that as well. Okay. With that in mind, let's get started here. So I'll boil this whole book down to you in one phrase. API management is making the right decisions in an evolving landscape while the ground is moving underneath you, making the right decision every time. That's all. It's easy. The problem is you don't control the landscape, you don't control the ground that's moving, and you don't control the questions you get. So it's even easier. But what does that really mean? So one of the things that we do is as I mentioned, we talk to customers a lot. We talk to all sorts of people. I was even talking to some people today about some of these same questions, asking questions. This has changed a lot in the 7 years the Academy has been speaking. 7 years ago, people would ask us, what's an API and why should I care? About 2 or 3 years ago, people said, yeah, I know what an API is. How do I make one? And over these last 2 years, people have been saying, yeah, I can make one, but how do I deal with all of them? So there's been this sort of progression, and one of these research studies basically says somewhere over 90% of the companies they talk to have some API or are going to have one soon. So this is not going away. We've always had APIs of one type or another. 15, 18 years ago, I was talking about SOAP services and why everybody had to have that. We all had APIs then. We've had APIs in code ever since there was the first library or first module. So it's not like it's something new. But the second part of this sort of webbish API space is barely half of the people surveyed think they're doing a good job at understanding what's going on and how it's working. APIs are supposed to have all this promise. It's going to be faster and cheaper, and you can just build a bunch of them, and everybody can treat them like building blocks. It never works. Why is that? What's missing? So that's really what we tried to tackle as we interviewed companies around the world and tried to ask them lots of questions. So what are the real challenges? We kind of boil them down into 3 things. First of all, this idea of managing APIs is a scope problem. Like I mentioned earlier, it isn't just one, it's many. And it's not just many inside one building, it's many inside the whole campus. And it's not just the campus in Ukraine, it's also the campus in Sao Paulo, Brazil, or the campus in Silicon Valley, or the campus in Australia, or all the other places it could be. There's just a lot to deal with in the process. And the other part of it is scale. So it's not just that there's just 5 or 10, but there's 500 or 1,000, and it's nonlinear. It gets more complex really fast. There's a hockey stick kind of model to this whole thing. And often what we do is we have tools that teach us how to build one, but don't teach us how to connect them or build them or scale them. And our little simple example works fine, but when we finally release it to the public, things don't work the way we expect because things were missing. We didn't understand them. We don't have good tools while we're building in order to understand what's really going on. And that leads to the next big challenge, and that is standardizing as much as we possibly can without slowing the process or stifling success. So a lot of our customers focus on very much a centralized standardization or centralized organization or governance. Some of our customers focus on a very distributed organization or governance. It turns out neither one of those is the answer, and there's a good way to start to think about how to do that. So in centralized organizations, there's usually one person or one group that decides what the APIs are going to look like, what formats you're going to use, what tools you're going to use, all of the details. And that sometimes becomes a thing that's called a center of something. Center of excellence, center of enablement, center of success, center of all the things good that go to die, whatever they want to call it. The challenge is centralized organizations are really relying on enforcement. So you will do what we do, you will go through our reviews, you will submit your material, and we will review it before it can go to release. And that makes sense, except it's really difficult to scale. When it's a small group, 5 or 6 people, maybe even 35 to 50 people, that might work. You start getting into the hundreds, and it gets really difficult to scale. You have to wait longer and longer for a review. You have to fill out more paperwork. You have to train more people before they can get started. You can't even really contribute in the first weeks that you join an organization because there's all these things that you have to do. Now, the exact opposite is this notion of where the decisions are made everywhere. Anybody can decide on what they want to do. And actually, there are speakers and authors and writers who talk about this kind of distributed or decentralized point of view. where anybody can build anything anywhere, and then they connect it up into the ecosystem. And if it doesn't get used, then it dies, and so on and so forth. The challenge for most of our companies that we talk to is that's a very expensive experiment. So anybody that builds something, it's usually costing them thousands of US dollars a day to start building on something. And if it's an even larger team, like if it's not 5 people, but 50 people, it's costing tens of thousands a day. And it may take them months before they actually have one working. And when they get it working, it may not work with any of the other ones, and all the other APIs now have to change for the new one. So this totally decentralized way doesn't work either. It turns out a great way to measure that we're finding is this notion of thinking about not who makes the decision, but what kind of decision they make. So in decentralized systems, there's an incentive. I will make good decisions because it's in my best interest to get my API approved and get it into the system and have it working with others. That's sort of the model. But it's sort of missing a few key elements. What we saw over and over again is there's a sort of a life cycle to making a decision, to getting something changed. Somebody gets an idea. We need to use a new library, a new tool. I just saw GraphQL, and it's very cool, right? So somebody has to start thinking about what tool are we going to use. So you come up with an idea, then the next step is to generate a series of choices. Well, we could use the Apollo library, we could just use the library that Facebook is using, and so on and so on and so forth. You start to generate these choices. And then somebody has to decide. Right? Somebody says, well, okay, of those 5, we're going to do this one. And this is where usually there's lots of arguments, people get angry, there's fists that fly, right? And then somebody has to actually authorize it. Well, you know, we're going to have to license that. We're going to have to get it approved by the company to be one of the approved elements. Then even after somebody decides it, somebody has to actually implement it. Now all of the offices need to support this GraphQL tool. That means operations is going to have to install it everywhere, and you're going to have to get trained on it, and so on and so forth. And then finally, at some point along the line, somebody's going to challenge the idea, you know, we've been using it for 6 months. Is it actually making a difference? Shouldn't we have used this other one instead? Do we still need this thing at all? And often what we miss is that these decisions, these elements of a decision are actually made at different places various times. And it's good that they're made in different places. So decision mapping actually becomes a really good tool for figuring out how your culture, how your organization gets things done. So here's an actual a sample mapping of maybe a programming language. Which parts are centralized and which parts are decentralized. So think of an organization, a highly centralized enterprise organization. So there's somebody on the committee for excellence decides we should probably stop using COBOL and use something else. So we're going to generate a list of choices, and we're actually going to approve 3 languages that anyone could use. They could use Java, they can use Node, or they can use Python. That's it. That's all you can use. 3. So we're going to let you, programmers, decide which of those 3 you want to use. We're going to decentralize that decision, right? And then your team can decide and authorize the use of that, and then you can do the implementation. You can use whatever methods you want to use. And then when it comes to challenging, if you don't like it, you can pick another one. So if you don't, it turns out you don't really like Node.js, you can move to Python or whatever. So what happens is we centralize the initial decision, and then we let everyone else decide how they're going to implement it and how they're going to do it and which one they're going to use. Sometimes that works, sometimes it doesn't. Well, let's look at another one, say maybe tool selection, an editor or some other tool. Maybe what happens is in your organization, somebody from the developer ranks or community says, you know what, I really like this new editor. Let's try using this editor. And we don't need a lot of choices. There's just one. Let's just think about it. We'll let everyone decide if they want to use it. The only thing is we've got to get it approved by that central agency that it's an approved editor and approved tool, and after that people can just start using it if they want. What you centralize and what you decentralize. And eventually they may come back and say, You know what? Nobody's using this. We're not going to pay the fees for licensing. It's gone. It's been challenged. So this can even go further. I'm not going to spend too much more time on this part, but this can even go further into the notion of your own general governance when it comes to design and implementation and deployment. Whether at the central level decisions are made or at the decentralized, at the team level decisions are made, is really something that you can deal with, you can decide. In a machine-driven space where most of it is all just driven by a pipeline, you just set up a bunch of pipeline rules, gates that everybody has to pass, and maybe the central committee focuses on building the Jenkins scripts and the other things and the test pieces and all these other things that are in place. And then it's like, look, do whatever tool you want, use whatever language you want. I don't really care as long as it passes through the pipeline safely. As long as it passes all the tests, as long as it meets the things, you generate the documentation, you've got your discovery document, you've got all that in place, then we don't care about the rest of it. This is essentially the way Amazon works. At Amazon, everything is just decentralized except for the actual process of going through the step. So the generation of choices, the actual thing that you're going to do, that becomes centralized. We use these formats, these languages, these semantic dictionaries. The rest is entirely up to you. They only care about that. In a much more collaborative experience, you might say there are lots of things that we're going to allow design. We're going to make design centralized so that everybody sort of understands what they are, but we're going to make the actual implementation decentralized. You can do it in any language you want. You can deploy it in any way you want. But then we're going to have measures that everyone agrees to know whether or not we're being successful. So one of the keys to doing all of this work is figuring out how you're going to mix leaning on the centralized way, which is enforcement, and the decentralized way, which is incentives. Every culture is going to be different. What's really challenging, we won't get to spend a lot of time on this, is as your system grows over time, to be successful and maintain the same pace, you're going to need to start moving the needle on what's centralized and what's decentralized. So every one of our chapters has a quote. So this is the quote on our governance chapter. I'm told that this, does anybody know who this is? I'm told this is no longer hip. We shouldn't have used Kramer anymore, right? Seinfeld is no longer a hip thing. But hey, if there's no rules, there's chaos. So let's talk about the API as a product side. So let's switch that notion of governance and sort of big picture to talk about design of your API. One of the key things that we saw is companies that are doing well are investing in teaching even their developers, not just their designers, a notion of design thinking. Design thinking was really promoted by this gentleman, Tim Brown, of the advertising company IDEO, advertising marketing company. Matching people's needs with what is technologically feasible and has a viable business strategy. Design is the process of solving someone else's problem that's important to the business in a way that's feasible and adds value. If you were in the UX talk today, you heard a lot about this notion about solving people's problems. So solving people's problems, technologically feasible, business viable. Now, when it comes down to what you need to do in order to solve those problems, we won't have a chance to talk about what API design is about or how you have an example of it. We give some examples in the book. There are some great books on it. But design is just one part of it. It turns out we identify 10 elements that are really, really important to this product mentality. And these 10 elements all have some role to play, whether it's the strategy on which API you're going to do today, which one's going to add the most business value or solve the biggest problem, using the design skills you have, documenting in a way that makes sense, the development process, testing, deployment, security, monitoring. We had a great talk about monitoring just earlier today. The notion of how I discover what APIs already exist or promote the ones that are there, and how I deal with change over time. How do I change things without breaking everyone else? These 10 pillars of creating APIs are all essential and all important. They represent an essential responsibility that has to be met. And you can put these in different bags. We have some companies that only have 5 or 6 of these. We have some that have 15 or 20. The key is if you don't solve every one of these problems, you're going to pay for it later. And companies do these in various ways. Sometimes they do this through training programs. Sometimes they hire someone from outside to deal with strategy or design, or they automatically generate documentation for internal use, so on and so forth. But you're going to have to settle on these. And then the other big thing, this is the one that people normally think of, is product lifecycle. Product lifecycle actually has 5 key steps we talk about. The actual creation process, which costs money and takes time. The actual publishing of something that's been created. You may create several and never publish them into production. And even after you publish them, they're not actually important until they're starting to realize value. They're actually starting to solve a problem. They're actually starting to improve sales or solve customer problems or reduce errors or so on and so forth. At some point, your API goes into maintenance mode. You know, it was a good idea at the time, and we've got a handful of important customers that use it, but nobody really cares about it anymore. And then eventually, it's true that nobody cares about it anymore, not even your customers. And you've got a better solution, and you've got a better set of tools, and that means you retire it. So we draw it as a life cycle. Of course, if it was a real life cycle, when you retired it, all the little bits and pieces would actually turn into a phoenix and start creating a new one, right? It would be a real cycle, but of course it's not. It's a straight line. It's a straight line from creation to retiring. But we all seem to like this word life cycle, so we use it. So you can actually look at, I'm not going to dwell on these, but you can look at each one of these life cycle phases as where the skills are most important. In the create phase, in the publish phase, in the realize phase, in the maintenance phase, in the retirement phase. And you can see that there's this burst in the publish and realize space, and then there's this calming effect in maintenance. Knowing where you are in your life cycle is going to give you a chance to understand how much time and money you should be spending on it. Just like any other product, we're in a phase where the product is actually, we're looking to just milk the most value out of the existing product. We're not investing in it anymore. There's no reason to do that. Now is the time to harvest, right? And that's what maintenance is about. George Kennedy is an amazing actor. He died several years ago, but he has this great quote about when you think about a movie, it's just a 2-hour movie. You think, well, that's a 2-hour movie. But it actually took hundreds, maybe thousands of people, months and months of full-time work to get that 2-hour movie. Often creating an API as a product is a life cycle experience that lasts months and months and involves lots of different people along the way. We forget that sometimes. We think that we watch the demo on stage and it's like, oh, that's easy. But it can take a lot. And that leads to the idea of teams. And when we talk about teams, people say, what should be, what is the perfect API team, or what's the minimal API team? Instead, we talk about this notion of roles. Our experience is that companies have teams of various sizes. They have titles of various types based on their own inner culture. But what they always have are 2 key elements. They have the sort of the business element of an API and the technical element of an API. Now, we have some general names here. Often they're called different things: product managers, product owners, stakeholders, so on and so forth. But some of these are kind of arbitrary. We have a lot of people that it's very important who's in the business, like they're on the business side, so they have to tell the technical side things, or the technical people have to protect themselves from the business side. There's lots of cultural elements. So we reflect some of this. But what we've got are these patterns of roles that have to be fulfilled. And just like we talk about the pillars as essential responsibilities, the roles are the scope of responsibility. The API designer has the scope of the design details in all the phases, right? The lead engineer and the API architect and the QA people and the DevOps engineer, these all are roles that have to be filled at various times throughout the cycle. So it doesn't matter if you have one person who's doing all this, right? I have some customers, they have one person that's maintaining the whole API. Or if you've got 5 people that are all, stuck together and they go through the whole life cycle, or if they're borrowed sources, like we borrow documentation, we borrow design, or we borrow evangelist or dev relations from some other place. It doesn't really matter as long as these are covered. And they're covered at different points, just like there are different things, different skills and pillars. There are different roles that need to focus at each step along the way as well. And these aren't just the only people that need to be working, but these are the people who have a critical role in the success of the API. So now we're actually talking about these pillars, these skill sets, and we're talking about the maturity model, and now we're talking about the roles that get filled at this maturity model, right? I can't go through the idea of teams or the topic of teams without mentioning Spotify. We know this, Spotify, right? Spotify has this amazing cultural element to them. We learn so much when we talk to Spotify about how they arrange their culture. They have this model where each team is called a squad. It's up to 7 people, and that is a skill set that is autonomous. They can complete a task that's on a board, or they can solve a problem all within themselves. Several of those squads get together and they form a tribe. A tribe is usually a product owner, so they're the Android app tribe or the web app tribe, or it might be a feature, the search tribe on the website, and so on and so forth. But what's really interesting about what they're doing is they recognize that individual teams on individual products is a problem. Because what's going to happen is you've got database people on each one of those teams or in those product spaces. Are they talking to the other products? If you're not careful, they won't. And each product will be trying to solve the same problem. They might be doing it differently, doing it with different tools, and all sorts of problems come up. So they create this notion of chapters across a tribe. So all of the data folks or all of the DevOps folks or all the designer people can get together on a regular basis and talk about what they're doing in their squads and what tools they're using and what techniques they're using, so they can make sure to help each other in the process. And at the same time, across whole product groups, they have this thing called a guild. So a guild is sort of like people who are interested in that other product, or how is it that they do it on the web, or how is it they do it in the Android or the iPhone app, and so on and so forth. And that makes sure that people are well informed, they understand each other without having to do their job, and that gives them some mobility. Because one of the things that happens for teams is if I'm just the DB person on this one team in this one product, if you move me to another one, I don't know what's going on. They use a different language, a different set of tools. Nobody ever told me about this. So you can have some problems with mobility. And they're very big on mobility. So there's a great article called Scaling Agile at Spotify. I encourage you to read it, and they have some videos as well. Just a few other elements on team and culture that I think are worthwhile. Leveraging Dunbar's number. Who knows this Dunbar's number? So Robin Dunbar, a psychologist, a British psychologist, has this notion that in our brains we have limits on how many people we can keep track of. The most popular Dunbar's number is 150. That's the number of casual acquaintances you can keep in your head. Every time I meet somebody new, somebody gets kicked out. And they're getting kicked out every day in my job. So sorry, I'll keep you in there for a while, but it's usually first in, first out, I got to be honest. But Dunbar's number is actually, the most effective thing is 3 to 5, he says. And 3 to 5, he calls it an intimate group. You rarely have to tell each other. You don't write memos. You don't talk much, but you understand each other. The next level up is around 15. You have to have a little conversation, but everybody knows what we're all doing. We're all heading in the same way. After you get up past 15, there's 35 to 50. Somebody's going to have to start writing memos, calling meetings. After 50, there's somewhere around 150. Somebody's going to have to add an HR department and legal. And pretty soon, that cool startup is the size of a company, and the culture's changed, and somebody says, you know, this used to be a fun company to work for. Culture changes at every step. It's no mistake that startups are usually 5 to 7. Startups don't start out at 150 because you have that intimate group. So leveraging numbers is important when you're setting your teams. Conway's Law, does anybody know about Conway's Law? Conway's Law is basically the communication apparatus that you have is the product you get. If you have 17 groups, you're going to get 17 modules that work together. If you got 5 groups, you're going to have 5 modules. You add another group, you're going to get 6 modules. If it turns out that everything you do has to be written out in a memo and has a big long meeting, the code's going to be a mess. There's all these things that go into it. There's some great stuff about Mel Conway's How Committees Invent article. There's more, not just the Conway's Law, which was named by Fred Brooks, but there's several other laws in that article that are very powerful. There's one that my colleague Ronnie Mitra in the committee, in the API Academy mentioned, which I really love. Alexander's Cultural Mosaic. Christopher Alexander's. Anybody know this name? Christopher Alexander is the one who gave us patterns, who helped the object-oriented, gave the object-oriented folks an idea of what object orientation and what patterns look like. And he did it in physical architecture. One of the ideas in Alexander's thinking is that the physical architecture affects how people communicate. And I can't go into the details here, but he has a cultural mosaic model of 3 levels. One level is where everyone is separated by who they are or some shared value. All the database people are here, all the testing people are here, all the architect people are up, I don't know, on the 17th floor somewhere, right? That's a ghetto. Every one of those is a ghetto. Everyone is like, all the database people hang out together, and like, we hate those people over there in ops and so on and so forth, right? The other element that Alexander talks about is where everybody works with everybody all the time, right? We're all equal here. We're all associates here. We're all on an even keel, and nobody's ever happy. Because we're not on an even keel. You've been here 17 years. I've been here 3 months. You know a lot. I barely understand things. So this idea of either separating people by who they are or what they are, or making everybody think they're supposed to all be the same, these are 2 very unhappy elements. His third element is an element where people with similar interests group together with a strong boundary. And if you think about it, that's exactly what Spotify does. We work on this product together. There's lots of people here, data people, design people, ops people, language people, and we all working on this toward the same goal. And that's his notion of how to create strong boundaries. And when you think about working in microservices, one of the key elements of microservices is defining a strong boundary. Eric Evans' whole domain-driven design is about creating a strong boundary and cohesion inside. And there are lots of other examples of that as well. The other thing that we saw a lot for companies that do APIs well and manage them at large scale is that they support a lot of experimentation. There's enough play in the organization that if you need to take a day or a week to go off and try something, you can do it. Google used to call it 20% time. 20% of your time is your own. You can invent whatever you want. So they invented Maps, Gmail. What was that other thing, that chat thing that they invented? Does anybody remember? What was it? Wave, yeah, right. Not all the inventions are going to be great. But this idea of supporting experimentation becomes really important in that culture as well. Steve Jobs said it pretty well. Great things in business are never done by one person. They're done by a team. There's some irony in Steve Jobs saying that if you know Steve Jobs' culture and history, but the quote, I think, is still powerful. All right, we'll talk about one more thing. And that is this notion of landscapes. So we've talked about the idea of governance and decisions. We talked about this idea about how it takes this API product point of view to work. We talked about teams. So what does it really come down to? So one of the authors of the book, one of the key authors of the book, Eric Vilde, has this notion of landscapes. Landscapes provide the environment that makes everything effective, that makes designing and implementing and operating them worthwhile. The fact that I'm going to build one and put it into the ecosystem, into what he calls the landscape, it's really important that that landscape makes sense. So what does that really mean? What does a landscape mean? So landscape is actually everything you have. So you have a thing called proto-APIs. They're not really APIs, but somebody built this little FTP app or this batch script that kind of moves things from A to B. That's an interface. That's a job. Somebody's got to maintain that. And it doesn't have anything to do with REST or SOA or any of that crap, but it's really important because we need those batch file runs every day. You have to adopt a platform principle, an idea that everything we do here is part of the ecosystem, is part of the landscape. It's not just the people working on the fancy new tools. It's the mainframers. It's everybody involved. It's everyone that touches data that's key to the organization. And you have to embrace the idea of continuous architecting. So we're going to change this part over here. We're going to leave everything else alone. Once that settles down, we're going to change that part over there. It's not like we build this grand design and then look at a large stone, carve it out, and then say, done, walk away. Because as we know, by the time you build any part of the system, the rules have changed anyway. Well, we don't really do it that way anymore. We don't really have that customer anymore. They didn't really want it anyway. Things keep changing all the time. Finally, he talks about this notion of API the APIs. So create the tools that allow you to use the tools to solve the problems. And this is a pretty common strategy. This is the Unix strategy as well, right? Create the tools like SED and AWK and grep and EDLIN and all these other things that allow other people to solve problems when they put the tools together, right? So you already have some kinds of APIs. You're going to have a platform. It's always going to be changing, and you're going to have to figure out how to manage them using the same techniques. This is what your API landscape looks like. Some of your APIs are in create mode, some of them are in maintenance mode, some of them need to be retired, some are actually fulfilling their strategy. This is what it looks like all the time. You're not all marching to the same beat at the same speed with the same tools or the same goals. There's all sorts of things inside and out. Some of these just need to be maintained for a long period of time. Some of them need to be retired because the company no longer is even licensing that software, so we're going to have to solve this problem. This is what the API landscape looks like. And that really sets us to our last sort of collection of things to pay attention to, what we call the V's, the 8 V's. And these are all elements to make us think about what's really going on inside your organization. And this is where time is really important. So we have lots of examples in real life, you can probably think of them, where it turns out that as time goes on, when we first built an element, it was pretty simple, not too many people used it, and I didn't need to worry about it too much. But then 3 or 4 years later, that one simple element dies, and thousands of apps all over the place are suddenly not working. What the hell happened? Well, over those 2 years, thousands of people started using that one little NPM package that shifted, that padded everything left, right? Nobody paid attention. Nobody knew how much that was growing. And as that grew, it added vulnerability. As more and more people started using this simple little routine, it added vulnerability to the entire system. And it happened because we weren't paying attention. Same thing for variety. In the beginning of your life cycle, of your landscape, you don't need a lot of variety. We use this tool for build, this tool for pipeline, this tool for test, that's it. But when you start doing it in various parts of the country, various parts of the world, they're going to use different tools. You're going to have to increase your variety in order to maintain your agility. You're going to have to manage vocabulary, you're going to manage versioning, you're going to have to be ready for volatility based on speed and time and all these other things. The V's actually represent inescapable challenges. You can't ignore them. Well, you can ignore them, and we see people do it all the time, but then you pay for it. Suddenly, there's a change in vulnerability. Marriott didn't realize that they were releasing servers that didn't really protect data well, and 500 million accounts at the Marriott and Starwood hotel data system are now exposed, including passport numbers. That vulnerability wasn't there in the first day. It grew over time. Increasing visibility helps a lot. That's why you see a lot of dashboards. Martin did a great talk about the importance of dashboards. The important thing about dashboards, have a dashboard. Start dealing with it. So you can actually match up these same vulnerabilities, these same challenges with all of the pillars we talked about earlier and figure out which ones really make a lot of sense. We spend some time talking about some of these in the book as well, so you can get a sense of what's going on. I love this quote from Donald Knuth. Programmers spend far too much time worrying about efficiency in the wrong places at the wrong time. Does anybody know the next phrase that comes right after this? Premature optimization is the greatest evil. So I love the first part of this, right? We spend too much time worrying about the wrong things at the wrong time. All right. So we need to face the challenge of scope, scale, and standards, how we solve this problem. And it's a challenge at scale. And we can do that by focusing on the way we make decisions and the parts we make and how to distribute that. We can give people the power to select from a list, okay? That's going to be fine. You know what? We support 4 formats here. Pick one. We need to embrace the 10 pillars, these essential responsibilities of strategy and design and deployment and all those kinds of things, and we need to apply them to that life cycle. We need to pay attention to when we're in maintain mode or realize mode or retire mode. We need to acknowledge the roles that we have to play because that's the scope of responsibility. Are you in charge of design? Are you the lead engineer? Are you in charge of architecture? If you can't answer those questions, it's likely not done well. And then you match those to the maturity model. I need you now because in maintenance mode, these are the people who need to focus on this. And finally, you have to embrace the entire landscape. And by the way, the entire landscape includes the people in it, right? The people are part of the system. They're not outside the system. So all of that stuff has to be dealt with, and you have to face these challenges and look at these over and over again, and be aware that time affects the various elements in this. Time increases vulnerability and volatility, and volume and velocity and things like that. Because all it is making the right decisions in an evolving space. Changes every day. I like this last quote from Henry Mintzberg, who's a business professor. Management is the practice where art, science, and craft meet. There's no one way to do this. We have customers that say, just tell me the thing, like which one of these 10 should I do? It's not the way it works. You have to manage this yourself along the way. But giving you handles, giving you things to look at on the small and on the large is really the key to success. So I just want to say thank you very much. Yakuya, thank you, and hopefully this will give you some ideas. Thanks. Do we have time? No, we're done? We have maybe time for questions. You stop me if anyone has a question. I've scared you or worried you, I don't. Yes.
Hi, thanks for a great talk. I'm curious, what do you think about GraphQL? Because it doesn't solve, obviously, all the challenges, but it responds to many of them, which you mentioned, like versioning and volatility. Yeah,
so GraphQL is a great question. We do have several customers that either have it on their experimental list or they're sort of deep into it. And sort of the marquee companies like Netflix had already invented one. Does anybody remember what they called theirs at the time? They have one that's very similar. If you think about RDF, it's basically the same idea, linked data. So there's been a long history of this, what we call basically remote data, right? This goes back a long time. So I think that the really beauty thing of GraphQL is they have great developer experience. Doggone it, I can sit down, I can do a query, I can start messing with that thing, I get feedback right away. Type, click, go. That's so much easier than most of the REST stuff, and it's infinitely easier than trying to do hypermedia decoupled. There's no tooling for that. So I think it solves that problem really well. The second thing is, remember, if you think about it, Facebook's problem was their front end made too many demands on the back end. We need this screen, we need this tool. Marketing was saying, I need another screen to see how many people I can get excited about this really depressing thing. And the back end couldn't keep up with it. So basically they invented a way to say, look, here's the data model, go ahead and go nuts. Develop whatever UI you want, don't bother us. So I think it does that really, really well. Now that makes sense inside a company, right? Because I think one of the biggest challenges that GraphQL has is security. I really don't have a good built-in security model, and I don't want to tell everybody what my models are because they may not all be privy to that information. So I think it's a kind of a two-way street. But it's not something that's new. We've had this kind of remote data modeling for a long, long time, 20 years or more, and we'll continue having it. I think they did a really good job at developer experience, and when you focus on the problem they were solving, I think they do a good job. That's my feeling. We have some customers that are actually very excited about it. There's some challenge in that you're all in on it too, though. The problem is you have to understand the whole thing before you start, right? Which is a bit of a challenge. That's going to be interesting to watch for us. Yes. Do you have time for one more? Are we done? Is it between me and whiskey? Is that the problem here? Because I only came for the whiskey, by the way. So if I have to talk, I'll talk, but I came for the whiskey. Were you going to say something? Oh, okay. One more? Okay. Thank you again. You can sign up for a newsletter and find out what I'm working on next. I'd love to hear from you again, and I'll be around here the rest of the day today and all tomorrow as well. Thank you again. Thanks.